Okay, and welcome to this brief introduction to LaTeX. My name is Veronica Heimsbach, and I'm a knowledge graph nerd at Capgemini in Norway. This video is recorded for a client, but it will get published also for others to hear. Okay, so what is LaTeX? Well, it's actually a document markup language that was released in 1984, so it's quite a grown-up language. And LaTeX is an abbreviation for Lamport Tech. So that means that it was Leslie Lamport, the genius from America that is behind Lamport Tech. And fun fact, Leslie Lamport actually received the Turing Award in 2013 for his work with distributed systems. You can find whole LaTeX release at this GitHub link. So Tech then, what is Tech? Well, Tech is also a typesetting system released in 1978 by the genius Donald Knuth. It was developed to let anyone on any machine create books and typography to perfection and documents of high quality on any machine. You know, back in the 70s, that wasn't given that the same program will run in the same manner from machine to machine. But Tech did. And Tech is actually an abbreviation for Techen. I don't know how to pronounce that because I can't speak Greek, but it's the Greek word for art and craft, and it's the root word for the English word technical. So it's quite descriptive of its purpose. And you can find the whole source code of Tech at this link down here. So how to get started? Well, you would need a text editor, whatever, and you will need a Tech compiler or a LaTeX compiler. Since I'm stuck with Windows at the moment, I use TextWorks, which is the Tech editor or text editor from the TUG group, and TUG stands for Tech User Group. I use package handling with MikTeX, which downloads LaTeX packages behind the scenes for me to use. On Linux, you could use apt to install TechLive, or if you are a browser-based type of person, you could use Overleaf. So let's get started. I'm sorry for the Norwegian in the header here. I was going through my slides and translating them just a few minutes ago, but seems I forgot something. Well, every single LaTeX document starts with a document class, and here we state what type of document we are creating, and also some options to the document class itself. And then every single document, the content of it, that is, starts with begin document and end document. For this tutorial, I will use the document class article. And there's a lot of different options for document class. And in my case, I've used a 4 paper and a 10-point sizing overall in my document for the bread text, that is. So let me do some live coding for you. So this is TextWorks, and it has autocomplete. So if I start to write and then hit Alt, it will give me what I'm looking for in most cases. So I'll go for A4 paper, 10 points, article, and then I need to write begin document and end document. And in here I can write anything I like. This is the content that gets compiled. You can write a lot of stuff outside of the document class as well, or the document environment, but that won't get compiled into your document. Okay, so let's start with the basics. Hello world. Compile that, and compiling in TextWorks is just pushing Ctrl and T for compiling. So this is my document, Hello World. I get page numbering by default. You can turn off that if you want to. I won't cover that in this tutorial, so I'll keep the numbering present. Hello World. And I'm also using the standard typeface for LaTeX. Okay, let's get back to the slides. Other kinds of document classes are book, report, minimal, beamer, etc. This presentation is written in Beamer with my own Beamer settings for the layout. Packages. It's all about packages in LaTeX. There is a lot of different packages for everything you can imagine, and one of them, or many of them, are for language and typefaces. And when I write in Norwegian, I usually use the package Babel with the option Norsk for Norwegian. That's just Norwegian in Norwegian. It supports every imaginable language. Maybe not in Babel, but in some other package. But Babel contains the most usual languages. And then I use the package input-enc, which tells me something about the input encoding of my document. And I want to write in UTF-8. So like I can write A, Ö, and Å, these weird Norwegian characters. And then I'm using the package font-enc, which is about the decoding or the output of my document and my typeface. And there is a lot of other packages as well. And we're going to look into HyperF, listings, GraphicX, also ticks, and some other kinds of snacksy stuff during this tutorial. But first of all, let me add the use package UTF-8 input-enc, because now I can write A, Ö, Å. So you see here, A, Ö, and Å. But if I comment this out, and comment is used with this percentage sign, and compile it, I still got them, which is quite weird. Okay, never mind that. I'm so sorry for this. Okay, anyways. I want the font-enc as well. Use package T1 font-enc. And these options and codings are described in the documentation of the package. Okay. Let us move forward to author and title. So I want to add a title to my document. And I'm adding a author, which is me. Like that. And bear in mind that title and author is stated outside the package. It's outside the document environment itself. So at the beginning, or anywhere you like, we must use the command make title in order to get it written or compiled onto our document. So here we go, my document, author, me, and date. The date is automatically added if you don't state otherwise. So if you put on a empty date command together with the title and author, it will remove the date. But let's keep it just in case. And if I had used a Norwegian Babel package, the date would have gotten a Norwegian format and written in Norwegians, like februar instead of February. Okie dokie. Sections. It's all about sections, right? Dividing the content into stuff. So let me just find some random text. Just give me a sec. I should have gotten this before I started the tutorial, but anyhow. Okay, here I have some text. and I'll add a section. This is a section, and I compile that. Ta-da! We have a section, and every single section gets a number, so it's enumerated, unless you put on the star between section and the title of the section. But please bear in mind that when you remove the numbers or enumeration from sections, they won't be a part of the table of contents. Table of contents. And with any LaTeX document, you have to compile it a couple of times in order to get everything updated. I'll remove that font tank since I won't print this document. Okay, so this is a section. However, if I put on the star, it's gone. But you could, of course, mix and tricks that, so it gets in a table of contents anyhow. That's not a part of this tutorial. Okay, let's split the text. So let's say I want a subsection here. This is a subsection. Maybe not punctuation in titles. Sorry. So this is a subsection. And you see, subsections get enumeration with the section it is in and the number of the subsection. Same goes for subsections. Subsection. This is a subsection. Sorry. Okay. So now you see the enumeration follows in the same pattern. And if I were to add even more sections, it will always follow the numbering of the main section. So you have like 2, this is a section, and you have 2.1, this is a subsection under section 2. Got it? Perfect. Okay, let's remove the last 2 here, and we'll start on, I think it is, paragraphs. So if section is not enough for dividing your texts in these 3 levels, you have section, subsection, and then subsection. It's possible to create some paragraphs as well. This is a paragraph. And you even have subparagraph. Okay, subparagraph. This is a subparagraph with some text. And that looks like this. But you can't divide the text even further. So if you need to do that for some reason, you have to invent it yourself. But if the question is, can I do something in LaTeX when it comes to documents? The answer is usually yes. Either it's a part of LaTeX out of the box, or it's a part of a package, or you could write a class file yourself. No problem. Okay, and then we have some MISC stuff. You have already seen the comment, but I could add another comment. So if I comment out this line here, and I compile it, I see that this subsection is empty, apart from the paragraphs, of course. So that's a comment. I can add one for the sake of it. This is a comment. And then we have new lines. So I can add a new line here. You see, we got a new line. And you could also write new line. But the shorthand for this is just double slash. So, how do we write percentage, you ask? Well, you have to put a backslash in front of it. And that's the case for many, or not many, but some signs, like the dollar sign, like the hash sign, like these brackets, and the backslash itself, yes, text backslash. That's a hard one, but how many times do you use backslash really? Oh, never mind those. Like that. Sorry. Okay, let's move on to fonts. Okay. So if I want to do something fancy with my fonts, I could, for example, create this as a bold font. Like that. The following as italic, text IT. And maybe I want to underscore something. And then I use underline. Let's see, I don't remember if this is out of the box in LaTeX, but we will try. Yes, it was. Okay. And there are several packages for styling your fonts. So we have Soul for strike through capitals, spacey stuff. I don't know what to call this. And my Beamer template and Beamer font doesn't work with this, so I can show you how it looks like in LaTeX. So if I use package Soul, and then I write something caps. This is cool. It will look like this. You get the picture, right? Great. Okay, and you also have the package color, which let you use the command text color, where you give, oh, I forgot to update example again, sorry, where you give a color and then the text itself. So we can do that as well, I think. So if I go up here and use package color, and I will write some text color teal, some text like this, and compile it. Teal wasn't defined. Okay, take red then. You will see then that you have some red text from that text color command. Sizing fonts. We have some predefined commands for sizing stuff from tiny to huge and almost everything in between. You can of course create your own sizing as well, but how much do you find that useful? I don't know. But let us add a huge text. This is very huge. And see how that looks like. So then you see this very huge text. Okay, typefaces right out of the box. We have the normal font, which is the font that is default for the document you're writing. For this Beamer template, that's a grotesque font or a sans serif font. RM family is the default for ordinary articles. So that's a font with serifs. And you have a typeface font where every single character takes the same space in your document. So that's nice for like short typefaced examples as code and so on. But there is a lot of different fonts to choose from. LaTeX have this font catalog, and if we look in serif fonts, we can see that there is a lot of stuff to choose from. And if I go for one random, I can see a example in Danish, and then I see the usage, and I can see the different kinds of font faced with that. So I can see the italic and the bold one. I can also see some special characters. Yes, and there's somewhat different usages from font to font, but anyhow, you get the point. So there is a lot of fonts to choose from, not only sans serif and serif font, but also typeface fonts. We have fancy fonts. We have weird fonts. Yes, so there is a lot of different things. Okay. Tables. Let us create a table. So I'm going to type the command for hopping to a new page, which is new page. And then I'm going to add a section on tables. And I'm going to create a table. So the environment for tables are called tabular. And here we write in some options. And the options state whether the column should be left aligned, centered aligned, or right aligned. So L, C, R. So here I'm telling the tabular environment that I'm going to create a table with 3 columns. The first left-centered, the second center-centered, and the right right-aligned. So I'm typing 1, 2, 3, and that's my first row in the column. So I split cells with this ampersand symbol. I don't know if ampersand is ampersand in English. I hope so. And if you want to write this symbol in plain text, you use the backslash in front of it. And to state a new row in the table, you use the new line symbol. 4, 5, 6, 7, 8, 9. Like that. Oh, I'm still in a very huge environment. I need to package it in. If I can hit the correct button. Okay, there we go. So 1, 2, 3. I will scale this up a bit, not that much. Maybe that's fine. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And we see that the first column is left aligned, the second column is centered aligned, and the third column is right aligned. And if I want to put some borders on this, I use the pipe symbol to assign borders between columns. I can even put as many as I like, doesn't matter. And in order to state horizontal lines in my table, I use the command hline. And there also I could pop in as many as I like. And see the table gets split if I put in 2 hlines in after one another. Like that. Sorry. Okay. Yes. And let us put this table in a table environment, because now we have created a table in the environment tabular, and that is nice. But if we put a table environment surrounding the tabular, we get a few more things we can do. And I'll get back to what this means in a second. But now we can do centering. We can, of course, use the environment begin and end center. But now we have the command centering inside the table environment. We can add captions and we can add labels. And I get back to why labels are important in a bit. Example. So if I compile this now, I see that my table got centered on the page because of the centering command. I also have a caption, some example table, and we see that this get numerated table 1 since this is the first table in my document. And I have a label tab example that is not getting compiled as content, but it's in there as metadata, and we're going to use it to cross-reference to the table. Yes, so let me do the cross-referencing. So let me capture some text and put it down here. A couple of chunks of text. And I want to reference this table from somewhere inside here. And then I use the command ref and give the label of the table I want to reference inside that command. And then I see I have the 1 number here, referencing table 1. And if I want the PDF to be clickable, I can add another package called hyperref. And we're going to use this later on as well to create hyperlinks in our document. Okay. I think that was the wrong button. I think I just misspelled it. Hyperref. Okay. Yes, I must have written the name wrong the first time. And now I see in the PDF view, it gets like this red box around it, meaning it is a link and it's clickable. So if I click it, it will take me to table 1, but it's in the same page, so not that interesting. But let us see. In order to do this cross-referencing, we need to tag the labels with the source of information. So for sections, we can put labels on sections. We use sec, subsec, so on. Figure, we use fig, tab for tables, EQ for equations, and ITM for enumerated list item. Okay, so then we go to figures. Woohoo! Let me see. I do think I have an image in my working directory, but that we will find out in a bit. Okay, section. Figure. Begin, figure. And then I'm going to use include graphics. But in order to include graphics, we need the package graphic_x. Okay, include graphics. And then I put on some options. So options are given in these square brackets. Width of 0.8 of the text width. So there is a couple of built-in parameters or variables in LaTeX, and two of those are text width and text height. We have several more, but those are the most important for a introductional tutorial. So what I state here is that the image that I want to compile or present in my content shall be 0.8 of the text width, so not the full width of the text. Capgemini.jpg, I think. Let's see. Maybe it's PNG. Let's try that. Whoa! Okay, just give me a second and I'll take a look in my folder to see what the image was named. Typical demo ghosts. When you think you are prepared, something is failing. Okay, it wasn't called Capgemini, it was called cap.jpg. Okay, let's try again. There you go. So if I remove this 0.8 and only use the text width, it will be as wide as the text block itself. But I don't want it that wide, so maybe 0.6 is better. Okay, I can live with that. And in the figure environment, I have the caption. And I also have the label. And I can also center this thing. But here I need to prefix it with fig, colon, and Capgemini, for example. So it doesn't matter what you name the label, as long as you have the prefix in place. Okay. So there goes for figures. And the figure placement, here it is. So you saw that in my LaTeX markup, I have this option to the figure and to the table environment, which is H exclamation. And that means H for hair, meaning hair, as in hair in the text, where I actually use the command. T, top of page, B, bottom of page, and this exclamation overrides internal parameters that fixes good float for the position. And large H or uppercase H equals to HT exclamation mark. But in larger documents, I will recommend to let LaTeX do the placing of figures and tables, because this is a document type system in markup language. You provide the content, LaTeX do the placing. And it's true, LaTeX actually knows better than you when it comes to typographical perfection and high quality documents. Yes. Next thing on the list is list. So let us create some lists. Subsection of lists. There is a lot of compiling in LaTeX, so there is a lot of time for sword fights. And that is something that us developers really enjoy, ain't it? Anyhow, let's start with lists. We have 3 different kinds of lists in LaTeX. We have itemize, we have enumerate, and we have description. Itemize. You might think it's only items in a list, and that's correct. So it's a bullet point list, basically. List element. And enumerate. Yes, they enumerate list elements. Enumerated list elements. Another one. And description. There you can give the list header yourself. Something. How nice. So there you go. And you can nest lists as much as you want. And they will get different headers depending on the level of the list. So here we go. Different kinds of list headers. Let's have a look at the enumerated list elements. Let's remove that one and copy this thing here inside and inside. Let's compile that and have a look. So we see here, start with 1, continue with lowercase letters, continue with I, and then continue with uppercase A. And the nesting of description isn't that interesting because you give the headers yourself, or the list head yourself. Enumeration, description, and then we have emphasize, footnotes, and verbatim. I wasn't supposed to go out full screen, but I was supposed to go here. Okay. New page, for example. And then I'm going to copy some text, and I'm going to emphasize some of that text. And that is the command emph. Compile that one, and we'll have a look. Let's see. Emph. Ta-da! It's basically just italic. And we can add footnotes. This is a footnote. And we see, since we have the hyperref package, this gets linked. So this is a footnote. And verbatim. So in verbatim, everything is allowed except from verbatim itself. So you remember the symbols we couldn't write without the slash, right? Well, in verbatim you can write anything you like. Where's the ampersand there? And it even fixes or ignores white space. So some sentence, this is a sentence. So if I put a lot of white spaces here, that will also be compiled in the content of the verbatim. But if I put this sentence outside of verbatim, LaTeX will see that here you have a lot of white spaces. You don't need that in the middle of a sentence, so it removes them and only keep it to one white space between each word. And that's quite nice. So that's another struggle with Word that disappears. Hyperlinks, we already talked about that. The hyperref package, then you could create URLs and hrefs, hyperlink references, and name them. And you can also access different kinds of schemas. So you could use mail to, for example, instead of the HTTP schema. So that's quite nice. And then we walk over to the mathematics. And that's the beauty of LaTeX, really. How we can do mathematics. Okay, so we have two kinds of environments directly in LaTeX. I will use the old environment from TeX because I'm most used to that, but it doesn't really matter. I'll show you both of them. So here is some inline equation, which is for all x in S. Or to be precise, I could use a small x. If I'm doing set theory here. And it will look like this. Beautiful, right? And if I want a, and then I need some highlighted equation. I do double $sign and end it with double $sign. So I do the same thing for all x in S. And please bear in mind that most of these commands for mathematical symbols are only available inside a mathematical environment. So here I get a highlighted equation. I'll add some text after that so you can see how it gets highlighted. So it stands alone in the middle of the page with a nice amount of space around it. So that's the environment from TeX. But we have a new environment in LaTeX, which is this syntax here. But I tend to use the $sign stuff. We also have packages for equations, and some of those packages includes the equation and align environments, which can enumerate your equations. So in a document with a lot of equations, that might be beneficial. You can also label equations and use the EQ prefix. Some symbols, but not the only ones. Let us have a look at maybe some of the most used ones. List of mathematical symbols. Here you go. And you also have the Greek letters. You have the trigonometric functions. You also have different typeface letters. But the comprehensive LaTeX symbol list is quite much bigger. So it's 422 pages of symbols from different packages and from the mathematical environment and from everywhere, basically. So this is a nice read. Really, really lovely. Okay, back to our slides. Listings, I want to do examples of that. I tend to use the verbatim environment for listings. Sometimes I tend to use the package color box to put it in a box, the code, that is. But I could at least talk a bit about the package LST listings, which let you write code in one environment, and it does syntax highlighting for you. And you can, of course, style your syntax as you like using the LST set. And these are the languages supported by LSD listings. So it's a bit old school, perhaps, but you can add custom keywords with the more keywords keyword in LST set if needed. Bibliography. So referencing is important in every document, and referencing to the source of information. And in LaTeX we have an environment called the bibliography, which is built in. But you also have a package called BibLaTeX, which is widely used in academia. But the bibliography environment is quite nice for a simple, easy referencing system in LaTeX. And then you use the command cite and the bib item key, or what to call it, name, that you set for your bib items to reference to that piece of resource in your document. Okay, and then we go to TIX. This is perhaps my favorite package overall in LaTeX, and it lets you draw vector graphics directly in the document by using LaTeX markup. So let us use the package TIX. Use package TIX. I'm not going to do any fancy TIX in this tutorial, but just to show you what we can do. And create a new section for it, perhaps on another page. Let's see how the space is. I usually don't put in these new pages everywhere, but just for this tutorial it's nice to divide it a bit. Okay, so I got a new page to play on, and I'll begin with drawing a line. So then we begin TIX, I need curly brackets, TIX picture, and we end the TIX picture. And I do a draw from coordinates 0.0 to 5.0. So the first coordinate is on the x-axis and the second is on the y-axis. It's also possible to draw 3D images using PGF, but that's not for this tutorial. And I draw the line to the point 5 in the x-axis and 0 on the y-axis. And that should give me a line of 5 centimeters, because centimeters is the default unit in TIX. But if I want another kind of unit, I could put on millimeter behind these points in the document. Then I get it in millimeter. So let's remove that. And I'll show you a couple of cool things you can do with this line. So I can give some options to the draw command. For example, I want this line to be ultra thick. And then I compile again. Ultra thick line. I can of course set my own thickness in millimeters or centimeters or whatnot. And I will have it as an arrow. It's so boring to compile. Arrow. And I can put a stop at the start of that arrow. And this can of course be reflected, so you can have arrowheads in both directions, or you can have stop in both directions, and so on. That's quite nice, ain't it? Awesome. And then I will use a text library that is shapes. And I keep going out of the full screen. I don't know why I do that. Okay, so I'm going to use TeX library shapes. Okay, see if I spelled that correctly. Okay, it doesn't get any errors so far. Okay, let me draw another picture. And now I'm going to draw a knowledge graph, of course. I'm a knowledge graph nerd. So, and in the shapes package, you get access to stuff like ellipse. I'm going to draw black. And I'm going to start on 00. No, I'm going to give it a name. 1 at 00. And it will be filled with Capgemini. My imagination is quite limited this late in the evening. It's almost 8:30 in the evening at my place. So there we go, Capgemini. And I'll copy this thing and go for naming the second node 2, and I'll place it at 5.0, meaning 5 points to the right of the first node. Call it a company. There we go. I'll copy this one again, name it 3. I place it still at 5, but slightly above 1.5 perhaps. France. Slightly above the company node. Compiling. Okay, I'll copy France. And I'll keep the y-axis, change the name to 4, push it a bit to the right, and call this country. See where I'm going? Great. Then I'll add some lines. And to add lines, I need to draw things. And I will draw arrows, not in that direction, but in that direction, going from 1 to 2. So here comes the names in the picture. So after this magic, I have drawn a directed line going from node 1 to node 2 from Capgemini to company. And if I would put a node on this line, I type in node behind the dash, and I can give it some options, and I will give it a name. And the name will be is a company, right? Because Capgemini is a company. Oh no! The line goes straight through. That's because this node doesn't have a background. So if I choose to fill this node with white, I will have a background. Like that. Or I can place the node somewhere else, maybe above the line. Let's try that. Awesome. I really wonder how many years of my life I've spent on compiling things. I'm going to fill the second one with white, just so we have both options here. Head core. I need to put on the spelling. Sorry, English is not my first language. Headquarters in France. So I need to point this arrow at node 3. Whoa! There we go. And another is a relationship going from France, meaning node 3, to country, meaning node 4. Ta-da! There we go. Okay, so there I have my tiny little graph. And I have a couple of one on trees in the slides. So on this node command, you can actually add childs as an own command. And for a child, you can give a node with some name. So you can build trees as this. And you can style every single node to be the same. But please beware that if you do this, you will also style this node. So if you don't want this node to be in a circle or an ellipse, you must give that particular styling a name, and you do that in a TIX set. But that is for another presentation. Okay, that's it, everyone. So, some closing words. Intelligence is finding an error in the Knuth text, but stupidity is cashing that $2.56 check that you got. That's it for me, folks. Thank you for listening. Some useful resources at the end. I'll paste this in any comment or description or somewhat for this video. Go play with LaTeX, folks, and see ya around.